Hello, my students. Now, today I'm going to be away, so I think maybe I pre-record this video so we can finish the last part of Saturday's lesson. You need to prepare your notes. Example 10. Given that y is a rational function, find the value of dy dx at x equals to 1. Find the derivative. Now, of course, we're not going to use the first principles. We're going to use the basic differentiation rules to find the derivatives. dy dx. Now remember, when you find the derivative, when you want to find the derivative at x equals to 1, and using the basic rules, you cannot substitute x equals to 1 to the function yet. Not before you finish the differentiation. So this one is d high, low, minus d low high divided by low squared. And then equal to 3 expansion 10x squared this second differentiation d low high. This function is a product itself. So inside the quotient rule, I'm going to use the product rule once. Differentiate the first one, multiply the second one, plus copy the first one, differentiate the second one, and multiply high divided by okay. And then it's long, 30x squared plus 33x minus 18 minus 5x minus 2 plus 5 2x plus 3 3x minus 1 2x plus 1 square 5x minus 2 square. Okay, now you can see to simplify this is a lot, but you can do it in the rougher sheet if you don't want the final presentation to be too long, but you do need to simplify it. We 30x squared plus 33x minus 18 minus, then this is 10 20x minus 4 plus 40 plus 11, 3x minus 1, 2x plus 3 squared, 5x minus 2 squared, 30x squared plus 33x minus 18 minus 60x squared minus 11x plus 11. Almost there, huh? Negative 30x squared plus 22x minus 9, 2x plus 3 squared, 5x minus 2 squared. I think that's it, unless I can factorize the quadratic polynomial in the numerator. I don't think I can. I don't think I can. Now I will just find. Now I'll do the substitution. And then use the calculator to find out the answer. Negative 17 divided by 225. Okay, that's all. That's all. Now, you may think about it. Now, what will happen if we do the substitution first? Now, let's say we put x equals to 1 inside the function, and to find the value of y first, and then do the differentiation. Can we still get the answer? I don't think so. I don't think so. Because after substitution, you will get a constant. And when you differentiate the constant, you get 0. So the basic differentiation rule, they don't work anymore if you only have a constant. So you must have x. You can only do the substitution after you are done with the differentiation. Okay. Now for this question, I put a lot of effort into the simplification as well. Now, do you really have to simplify till the end? For this question, I think maybe you can cut it short. You can cut it short. Technically, you can just do the substitution from here. Because inside this step, I mean, in this line, you don't have differentiation anymore. So technically, you can do the substitution here. But as a practice or as a demonstration, I want to show you just how normal you should feel normal to simplify such a thing in this subject. Now the classwork. You will find f prime x first, the derivative first, the derivative function first, which is d high low minus d low high divided by low square. Okay. Now for this one, the differentiation of the first function, d high, is quite complicated. I'm using the product rule again. So x plus 2, x minus 2, plus x plus 2, x minus 2, multiplied to x minus 3, minus 2, and then do the expansion. Because I know that in the end I have to expand. X minus 2 plus x plus 2, 2x minus 3, 2x minus 3 squared. Two x minus 3, 2x minus 3, 4x squared minus 6x minus 2x squared plus 8, 2x minus 3 squared. Okay. Now I'll put x equals 3 inside. Okay. That's the final example. Now, is there an easier way? I think so, but I just want to show you that you may have to apply more than one basic rules in one question. Now, in this case, you have a product inside the what is it? You have a product inside the quotient. Okay. Now later on, I will assign some more difficult assignment, homework assignment, so you can practice this rule. Now, this one, I think, let's talk about power rule again. I'm using this rule to end the lesson because, as I mentioned before, this rule hasn't been proven during the lesson yet. No. We have done a case when n is a positive integer. Now, in this part, I'm going to show you why this rule holds for n equals to a negative integer. So, the power rule, the proof of the power rule when n is a negative integer. F prime x equal x n prime equal 1 over x negative n prime. Now I do this because I know, knowing that negative n is a positive integer. Now, right now, it has a fraction, although the power negative n has a negative sign, but this negative n is a positive integer. And then now use the power rule. D high, low, minus D low, high, divided by low square. So 0 minus negative m x negative m minus 1 x negative 2m. In this step, I can apply the power rule because I know negative n is a positive integer. The power rule for positive integer is proved. So we can just use it. When something is proved previously, you can use it in your later proof. Okay. And then this is equal n x negative m minus 1 divided by x negative 2m. And that is n x m minus 1. So I think that's a proof when n is negative. In this proof, we used the power rule. We use the power rule, but only the part when the power is positive integer. We also use the quotient rule. Okay, I hope you had fun. I'll see you.